This conference will now be recorded.
Hello everybody, this is Alex with Fortress Power. This will be a re-recording of the webinar that we hosted on 4/29/2020 with Renvu due to technical difficulties. I want to thank everybody again for joining the webinar we hosted yesterday and apologize for any inconvenience due to the audio problems we were having. So without further ado, I would like to get this presentation kicked off and underway. So, like I mentioned in the webinar, we talked a little bit about the products that Fortress Power has, a brief technology comparison of the different batteries on the market, our quick design guide, the different services and tools that Renvu provides, along with the benefits of being an authorized installer. So I remember that Nick presented a little bit about the background on Renvu. Founded in 2002, it is headquartered in Mountain View, California, has fulfillment centers in the California area, Texas, and New Jersey. They have a pretty smart sales team that's comprised of engineers that can provide very thorough support. And they also have a bunch of free online tools to help with projects and help figure out what kind of bill of materials would be needed in that regard. Renvu's mission is to deliver quality solar products at the best prices with an exceptional level of knowledge and support. So here I'll go over the brief product introduction. So to start, Fortress Power, like I mentioned, is based right outside of Philadelphia, Pennsylvania in Southampton, PA. This is our warehouse over here. It's a 30,000 square foot warehouse. And we also have logistics centers in California and Florida. We have over 45 megawatt hours of installations worldwide, ranging from Latin America to the continental US, Canada, and even into Africa. We are the exclusive battery supplier for a local railway company right outside of Philadelphia as well. And we've seen a lot of growth with energy storage over the past few years we've been in business. We provide three different models of batteries: the eVault 18.5, our LFP 10, and our LFP 5. These sizes can range from 5 kilowatt hours to 200 kilowatt hours. This is because this eVault 18.5 can stack up to 12 or parallel up to 12 for 200 kilowatt hours of backup. The cool thing of the eVault is that it has this LCD display. And on this LCD display, it'll show things like the voltage of the battery, state of charge, current, and power. It'll also show if you have multiple batteries in parallel, which one is the master, as the batteries have a master-slave relationship, along with how many are in parallel. So if there were 6 in parallel, this would be the master. It'd have parallel number 6. Another feature of the LCD display on the eVault is that you see these little circles here on the right-hand side. Should there be a problem with the battery or something arise due to high voltage, this HV circle will light up, thus letting the homeowner know that is a high voltage problem to be diagnosed, therefore letting you be able to not only let us know about it so we can provide the best support we can, but give an idea of what steps would be needed in order to rectify the problem. I also want to introduce our newest product, the eFlex 5.4, which will be available in June 2020. This is a lithium iron phosphate 48 volt battery in a 5.4 kilowatt hour modular size. But some new features is that it will have closed loop communication with different inverters. It'll have a memory card for data storage. It'll have Wi-Fi remote monitoring through a cloud-based app, and it can also be wall mounted, floor standing, or put in a racking or shelf mounted solution. So I'm very excited for this unit for a lot of the different flexibility, hence the eFlex in that kind of way. I'm very excited to see that, and more information as it gets closer to availability will be provided. Here are some technical specifications on the 4 models of batteries we will be providing. I'm not going to go over this in detail, but I would like to point out that the battery voltage is 48 volts. And I also like to point out that we have a 10-year warranty for customers inside the States with up to 6,000 cycles. Like I mentioned, you can stack up to 12 of the eVaults. You can stack up to 15 of the eFlex 5.4s for 80 kilowatt hours, 2 of the 10s, and 3 of the 5s. The eVault is the only one that have the LCD display. All the other ones will not have that. All of the eFlex will have that remote monitoring capability. For paralleling multiple eVaults together, you'll be able to use an RS-485 cord to have the batteries communicate with one another, as well as communicate with the inverter. So an important aspect of lithium batteries in comparison to like a lead acid, for example, is the battery management system. A battery management system essentially is the brain of the battery and will protect against overcharging and deep discharging, overheating, low temperature, overcurrent, and short circuit and open circuit protection. So the BMS on the eVault and the eFlex is a contactor-based BMS, meaning it has all these protections, and it is a fuse and a switch that physically opens and closes. It's a very safe battery management system, and you can see that because of this BMS, it allows the communication with the inverters, communication with the different units in parallel if you have multiple, and it also have the remote monitoring capability. The cells in these units are prismatic, meaning that it is a square-shaped lithium iron phosphate cell. The difference with the prismatic cells is that they're a little bit more efficient, a little bit longer lasting than the cylindrical cells, but needless to say, there isn't that big of a difference between cylindrical and prismatic, just the way in which these cells are formatted. On the 5 and the 10, it is a MOSFET-based BMS, which is essentially a piece of circuitry, which will protect against the basic overcharging, overcurrent, and short circuit, but it is not as thorough or, let me say, smart as the contactor-based with the communication and the monitoring options in that kind of regard. So now I'll go over a quick battery technology comparison of the different chemistries on the market and the different ways in which lithium iron should be preferred in different applications. So you can see here, LFP has a very high round trip efficiency to start, 98%. Wow, definitely a little bit higher than the lithium ion or the lithium polymer, and certainly higher than the flooded lead acid or the nickel iron over here on the end. Also want to point out the energy throughput in megawatt hours of lithium iron phosphate chemistry. The energy throughput is the total amount of energy a battery can be expected to store and deliver over its lifetime. You can calculate energy throughput by taking the nominal capacity multiplied by the depth of discharge, multiplied by efficiency, multiplied by the cycle life. So you can see that LFP has a 47 megawatt hour energy throughput, while the competitors that use lithium ion or lithium polymer or even a AGM or flooded lead acid, they are not really comparable in terms of energy throughput. The only one that'd be comparable is this nickel iron chemistry at 41.6 megawatt hours. But if you look at the cost of a 10 kilowatt hour battery, it's almost 3 times the amount for a nickel iron in comparison to an LFP, which is going to bring me to my next point. The cost per kilowatt hours with lithium iron phosphate chemistry is much, much lower than that across the board with a few of these different chemistries. It is also one of the safest chemistries on the market and has no maintenance. So you'll see a lot of different batteries now starting to jump on the lithium iron phosphate train because of the long life cycles, the ability to have a lot of long off-grid years and high energy throughput, and the low cost per kilowatt hours. So I want to bring up this quick chart of a performance comparison between lithium iron phosphate and lead acid. This chart here on the left is essentially showing that with a higher influx of current, your capacity of lithium will stay the same across this way at 100%. Now you notice with flooded lead acid or AGMs or these gel batteries, as your current goes up, your capacity is going to drop. What does this mean? This means that if you are using a lead acid for a backup situation and the power goes out, for example, and you start powering a lot of loads and the current goes up, your capacity of battery is actually going to go down in a lead acid. So you're not going to be able to power as much loads in the event of an outage because you are having a drop in capacity as you power more. With lithium, you are really able to really put a lot of current into loads and have a consistent capacity. Next, I'd like to review the different technologies on the market. I threw around some terms earlier like LFP, lithium ion, lithium polymer on the previous slide. We use a lithium iron phosphate chemistry, otherwise referred to as LiFePO4. Some key features of this chemistry is the safety and eco-friendly, is that it can be recycled. It is also very thermally stable. There's also a lithium ion chemistry available on the market, something like a Tesla or LG Chem, and the safety of these is not as safe as a lithium iron phosphate. I'm sure you have all seen the horror stories regarding the Tesla batteries, because of the thermal runaway, because of the cobalt element added into the chemistry. Lastly, the life cycles of a lithium iron phosphate chemistry is almost double that of a Tesla or LG Chem, because the lithium iron phosphate is really best for stationary applications. While NMC might be good for the Tesla car because of the high energy density, it really makes sense for a stationary application where you need a lot of cycles to power loads. LFP is certainly the way to go for those kind of applications. And you can see here that the degradation rate of the LFP is less than that of the NMC and the lithium polymer. The lithium polymer is not too popular, but is commonly seen, in the batteries in your cell phone, things like that. So you'll see with most energy storage applications, lithium iron phosphate is really going to be the way to go. So I wanted to show everybody this video because it is really showing that between the lithium iron phosphate technology and the nickel manganese cobalt technology, or the chemistry that Tesla uses, really showing the safety of our chemistry. So they take, in this video, LFP versus NMC nail test video, they take a 10-penny-inch nail and puncture right through the center of this LFP cell. You can see throughout the video it does some smoking, but nothing too catastrophic. On the other hand, we take an NMC cell in a similar situation. We drive a 10-penny-inch nail through that, and it's a complete blow up. So I like this video just because it really shows the safety of the LFP cell, because most people's conception of lithium batteries is that they're going to blow up. But in this case, it's really demonstrating you can stick a nail right through the cell of this battery and nothing will happen. So a few advantages of the LFP technology is the safety, the high energy throughput, 47 megawatt hours, the long duration, the 6,000 cycles that we provide, and the low energy cost. So the very 14 cents a kilowatt hour, very, very affordable, allows the more bang for your buck, let's say. Next, I'll go over a quick design guide on our systems. So before I get started on that, we are compatible with a lot of the different 48-volt chargers and hybrid inverters available on the market, including Schneider, Outback, Magnum, SMA, Solarc, Victron, Morningstar, and Midnight. The ones with asterisks next to, we are establishing closed loop communication with these different inverters. So not one project can call for one kind of battery or one kind of inverter. So having flexibility with these different kinds of inverters really allows for more uses for different kinds of projects. Should there be an inverter on this chart that you're working with that is not here, please let us know and we can do more research to find out if that inverter would be compatible with our system. Next, I'll go over the Fortress Power sizing tool that we offer here as an authorized dealer. So what we essentially do is we find out the critical loads of the project. So here we have things like a fridge, light bulb, sump pump, well pump, microwave, computers. We take the watt hours a day and we figure out the total watt hours a day of these loads for the critical load consumption report is 18,000 watt hours a day. When selecting a battery bank size, if they wanted to back up all of these loads, we would take two LFP 10s at a 90% depth of discharge to get 18,432 watt hours of backup. So as we go through, and this is also can be found on our sizing tool, you'll be able to put in for a PV watts report your solar radiation and AC energy. And then what you can do is you can figure out that based in June, for example, they are creating 36,000 watt hours a day. They charge the battery at 18,432 watt hours. And this is the available energy after their battery is charged. So this can then be put back to the utility for net metering, back to the electrical AC loads, or even back into another battery in that kind of regard. One key thing to note is that in December, as you can see with lower radiance in states in the north, I'm in Philadelphia, so this would be reflective of maybe a PV watts report in Philadelphia, is that your energy per day in watt hours is lower than obviously in June, meaning that after one full charge on the battery, you don't have too much extra watt hours available after the battery is charged. So always letting the customer know, okay, you will have limited power after the battery is charged. Make sure that you're adjusting accordingly in December. So what we gathered from that is that the available power in battery at 90% depth of discharge was 18,432, which means it will power those loads we saw on the previous page here for one full day. So that is essentially how our sizing tool works to help figure out, based on this PV array and these electrical loads on the critical load panel, this size battery will power these loads for X amount of time. Next, I want to talk about this LFP discharging curve. So if you remember earlier in the presentation, I mentioned that the eVault has the LCD display on the front to measure state of charge. The eFlex will have remote monitoring. You might be asking yourself, how would I measure state of charge or capacity on the LFP 10 or 5? What you would do is take a voltmeter and figure out the voltage depending on the C rate to figure out the capacity. For example, 0.5 C, we measure the voltage. Let's say the voltage is at 50 volts. We then know that the capacity of that battery is at 80%. So it's just a quick tip for those of you that are wondering how to measure the capacity of the LFP 10 or the LFP 5 battery. Next, I want to bring up the temperature impact on lithium iron phosphate. So LFP has a very broad discharging and charging temperature. It can really range from 32 degrees Fahrenheit to 130 degrees Fahrenheit. And you can see here that the stipulation with temperature is it's not as it gets colder, even to the -4 degrees Fahrenheit, it doesn't stop charging or discharging. It is the rate of the charging or discharging which is affected. So although our batteries are primarily an indoor unit, which we really do recommend, should it be somewhere where it can be subject to colder temperatures or maybe warmer temperatures, the broad discharge and charge range will help, but at the same time, it'll be good to know that the rate of the charging and discharging will just be slowed down. Next, I want to look at cycle life versus depth of discharge. So as I mentioned, we recommended an 80% depth of discharge for the 6,000 cycles. If you were to cycle that one time a day, that's around 12 to 15 years. The reason why I put this chart here is because some of their batteries claim to have 12,000, 13,000 cycles. But what they're not telling you is that this depth of discharge is only at a 50% depth of discharge. So if you have a 10 kilowatt hour battery, you're only able to get 5 kilowatt hours out of that. So depending on the application of the project, whether it's a time of use rate, maybe 80% or 70% might be the way to go. But if it's a emergency power, you could really go to 90% or even 100% depth of discharge, depending on what the project calls for. For long life cycles, 80% would make sense since they're cycling it daily, i.e. time of use or off-grid. For someone emergency power who needs a lot of power, a few times a year, 90% depth of discharge or 100% depth of discharge might be the avenue to go. So always be cautious of when people say how many cycles they have, because it really depends on the depth of the discharge, their temperature, the temperature in the area, along with the charging and discharging parameters. So please note this moving forward regarding cycle life along with warranties. So a lot of the different parameter setting guides for the different batteries we have with those different inverters can be found at fortresspower.com/resources. But a thing I did want to bring up here is that we recommend 80% DoD for 6,000 cycles, 90% DoD for 3,000 cycles. Max charge current, 100 amps for the eVault, 90%, 170 amps. So with more depth of discharge, you will be able to put out more amps. More information on parameters and with the different inverters can be found on our website, like I said below. So if there are these other applications in which you're sizing a project for something along those lines, like the time of use, self-supply, or for demand curtailment for maybe some commercial projects, you can send your project information to sales@fortresspower.com, and I'd be glad to have a few of my application engineering staff take a look at that and see what kind of recommendation we could come up with in that regard. Renvu also offers a few installer services like on-site analysis, professional engineering services, logistics and warehousing solutions, and purchasing excess inventory. So please reach out to your local Renvu representative for any other questions regarding that. And the same with Renvu's solar kit guide and battery upgrade guide. Essentially, they're very helpful tools to help figure out for a particular project what a bill of materials may look like, or what a battery replacement may look like for a lead acid to lithium or another solution in that way. So please contact your rep at Renvu again with any questions in regard to their design tools. If you're interested in becoming an authorized installer for Fortress Power, What we will do is you will fill out the dealer application that we have. We will then provide the product and sales training with a webinar, somewhat like this one, but maybe more on the installation side. And then we will then end up with the design and installation training. So a lot of good benefits that our installers have is the sales and marketing support that I provide, the discount price that you'll get as an authorized installer. You'll get generous stock levels, technical support, and trainings for your team or for your customer. Thank you very much for listening to this webinar. And if you want to go fast, go alone. If you want to go far, go together. Please feel welcome to reach out to us at Fortress at sales@fortresspower.com, or for questions regarding Renvu's sizing and design services, please email them at info@renvu.com. Thank you again and have a great day.